give you some information on one of the important concept of pure rolling motion. Suppose there is a rigid body which is undergoing pure rolling on a surface. We suppose that we apply a force F on this rigid body at a vertical distance of h from the center of mass. Radius of the rigid body is r. Let's suppose friction acts in the forward direction. It may also act backwards, but without loss of generality, we can assume that it's acting forward because only the sign will change. So let's first see the condition of no slipping. We know that for no slipping, the point of contact must be at rest with respect to the ground. So we have E is equal to omega r. Differentiating this equation, we get dv by dt is equal to d omega by dt into r. We know dv by dt is the acceleration of center of mass and dw by dt is alpha into r. Now, on this rigid body, there are two forces. The first force is F and the second force is Fs. So according to Newton's second law, net force is equal to m into A. So we have F plus Fs is equal to MACM. So from here, Fs is equal to MACM minus F. Now if we take the torque of these forces about the center of mass, so you can see that about the center of mass, this force F will be producing a torque in clockwise sense, and we have taken that as positive. Similarly, the force Fs about this center of mass will produce a torque in anti-clockwise direction. We have taken that as negative. So we know that net torque is equal to I alpha. So the net torque is Fh in clockwise direction and minus Fs into r in anti-clockwise direction. So we have used Fh minus Fs into r, which is equal to I into alpha. From here, we can say that alpha will be ACM upon r. So we just substitute the value, alpha is equal to ACM by r. Now, if we substitute the value of Fs in this equation from here, what we get is this. Now we multiply these two terms and we have Fh minus MACM into r plus Fr is equal to IACM by r. We just take this factor on this side and we have ACM into I upon r plus Mr is equal to Fh plus Fr. So from here, ACM into this thing can be written as I plus Mr square divided by r, and F you can take as common, and we can say that this is F into H plus r. Multiply this r over here, we get ACM is equal to F HR plus r square upon this thing. Now I is equal to mk square, so we substitute the value of I as mk square, we get this result. Now we take m common, so we have ACM is F upon m and divide the entire expression by r square. यहाँ भी आप r square से डिवाइड करते हैं, यहाँ भी और यहाँ भी, तो ये आपका एक्सप्रेशन आएगा. And the final result will be this: ACM is equal to F upon m h by r plus 1 upon k square by r square plus 1. टाइम बचाने के लिए आप इसको रिजल्ट को याद रख सकते हैं, जिससे आप क्विकली इन स्टेप्स को बाई पास करते हुए डायरेक्टली आप रिजल्ट पे आ सकते हैं. अगर हम h को 0 करते हैं तो ACM का वैल्यू आएगा F upon m into k square by r square plus 1. This will be minimum for ring, because for ring k square by r square is maximum. And the value will be F by 2m. Just solve this how it will be F by 2m. Use your own mind. And the maximum for solid sphere, and the answer will be 5F by 7. The proof of this is left as an exercise for that. You just put the value of k square by r square. It is 1 for the ring and it is 2 by 5 for the solid sphere. I hope you understood the things. Thank you and have a nice day.